Good afternoon, everyone. Is the slide visible?
Yes, ma'am.
So let's start today's session. So good afternoon, everyone. Today is your problem solving session 12, and I am T. Vidushi. So firstly, we will solve some questions about the previous assignments. So in the first question, in NMR spectrum, the nuclei in up field resonate at high frequency, low frequency. It is constant throughout the spectrum, or it doesn't depend on the chemical shift.
High frequency.
No, like it is like the nuclei in the upfield. Upfield will always resonate at the low frequency. So the answer
Yes,
is
yes. Low
low
frequency.
frequency.
Low frequency.
Yes. So the next question: what happens when a spin half or 1/2 nucleus is placed in a magnetic field and irradiated at the Lambda frequency? The frequency of precision of the nucleus changes. No changes occur. Transitions are excited between spin energy levels, or the nucleus spins faster. So when a spin of half is placed in a magnetic field and it irradiates at the lambda frequency. So what will happen? So what will be the answer? When a nucleus of spin half is placed in magnetic field, there will be transitions are excited between the spin energy level. Now next question. Consider following isotopes like it's proton, deuterium, and both isotopes of carbon, nitrogen, oxygen, fluorine, and phosphorus. Which nuclei will be never inactive? So we already discussed like for a nuclei to be never active, it should have a known
Option one.
option one. Okay, like 2H. 2H is deuterium. Like we discussed, like how we can say NMR is that a particular
Sorry. Option three.
correct.
It should be divisible by 4.
Yes. If the no, it should not be divisible by 4. If suppose your mass number is divisible by 4, then the I value will be 0. So for NMR to be active, the I should not be equal to be 0. Should be a non-zero spin value. So as in carbon and oxygen, the mass numbers are 12 and 6 respectively. So as you know, as it has even masses, so it will be NMR inactive. Just remember that for a nucleus to be NMR active, it should be having non-zero spin quantum number. That I should not be equal to 0. Therefore, the mass number should not be divisible by 4. If mass number is divisible by 4, then the I value will be 0 in that case. Now next question. In an applied magnetic field, the possible number of orientations for a nucleus spin 1 are 2, 3, 1 or 5. So how many number of orientations are possible here if the spin is 1?
3.
3. And what will be that orientations?
Plus 1, 0, minus 1.
Correct. Now in the next question, it's nuclei having either the number of protons or neutrons as odd. They will have how much spin? It can be integral, half integral, 0 or positive. We already discussed like if the number of protons or neutrons
Even
are odd, then the integral will be
positive.
half integral.
Pos-
Half integral if they're odd. Now next question. Which of the following light exposure conditions would be most harmful to live cells or living cells? Yellow light, white light, red light, or blue light? So, which of the light exposure conditions are harmful to living cells? Yellow, white, red, or blue? Anyone? Arpita, Kartike?
Blue light.
Blue light, yeah, it will be blue light. Why it is blue light? Blue light has high energy. So blue light is the most harmful for the living cells. Now next question, FLIM, fluorescence lifetime imaging microscopy. It is based on measurement of polarization, lifetime, intensity, or the quenching of fluorescence on photobleaching. So what will the answer? The measurement of lifetime. This one. Dissolving power of microscope is a function of only Na of lens system, only wavelength of light used, and the micro aperture of lens system or refractive index. So what will the answer?
Option 3.
Correct. It will be the wavelength of light used and the aperture of the lens system. So the next question, in a specimen containing an active and a mobile microorganism, which of the following type of microscopies can be used to visualize them? Dark field, bright field, phase contrast, or fluorescence? If your microorganism is active and mobile, so it will be phase contrast
Face.
microscopy. Correct. Now next question. Which part of the compound microscope helps in gathering and focusing light rays on the specimen to be viewed? Lens for the eyepiece, a lens with a condenser, a lens that is objective, the use of a magnifying lens.
Option 2.
Correct. A lens with condenser. In light microscopy, the highest resolution is attained with visible light with longer wavelength, visible light with shorter wavelength visible light, and an objective with higher Na or a lens with a small numerical aperture. So you know resolution is like, what is the relation between resolution and the numerical aperture? Resolution is directly proportional to your numerical aperture. So for a better resolution, your numerical aperture should be very high and wavelength should be low. That is shorter wavelength visible light and objective with higher numerical aperture. The correct statement about photobleaching is a fluorophore reacts with a biological compound in a reaction catalyzed by photons. Biological compound interferes with the light source to prevent fluorophore oxidation. Light energy reacts with the fluorophore and cause permanent structural change, or none of the above. So what will be the correct statement about photobleaching? It will be light energy reacts with the fluorophore and cause permanent structural change or damage. That is called as photobleaching. Now next question. The rate at which light passes through objects in a phase contrast microscope is cannot be determined. Inversely proportional to refractive index, directly proportional, or refractive index are the exponentially linked. What was the answer to this? The rate at which light passes through objects in phase contrast microscopy. It will be inversely proportional to the refractive index.
When screen are visible,
Just a second. Is it visible now?
yes, ma'am.
Okay.
Yeah,
So,
ma'am.
so the next question is correct statement about photo bleaching. A fluorophore
And what
reacts
will be the answer of above one? That in light microscope.
uh, like for the first part, which part of the compound microscope helps in gathering? It will be a lens with a condenser. Now, in the next question, in light microscopy, the highest resolution is attained with visible light with longer wavelength, visible light with shorter wavelength visible light, and an objective with higher Na, or a lens with a small numerical aperture. So, basically, what is the relation between resolution and the numerical aperture?
Inversely proportional.
It is directly, not inversely. Resolution and numerical aperture directly proportional to each other. So, if you want to achieve a highest resolution, it can be attained by higher Na and a shorter visible light. This one. The third option correct. Now the next question, the rate at which a light passes through objects in phase contrast microscope is cannot be determined, inversely proportional to refractive index, directly proportional, or are exponentially linked. So it will be inversely proportional to the refractive index. Now next question, what will be the correct statement about photo bleaching? So a fluorophore reacts with a biological compound in a reaction catalyzed by photons. A biological compound interferes with a light source to prevent fluorophore oxidation, or a light energy reacts with the fluorophore and cause permanent structural damage, or none of the above. So what will be the answer for this? So what will be the correct statement about photo bleaching?
Option 3.
Correct. It will be option 3, that the light energy reacts with the fluorophore and cause permanent structural damage. So now, before solving some of the questions, we will discuss some little bit theory about the mass spectroscopy. Like we previously discussed about UV, IR, NMR, but now we will discuss about the mass. Like previously we discussed like IR spectroscopy, ultraviolet spectroscopy, but for mass we use the term spectrometry. Why we can't use my mass spectroscopy? Like for UV, IR, NMR, we were using the term spectroscopy. But for mass, we are using the term spectrometry. Anyone? Like what is spectroscopy?
Study of interaction of
radiation with the matter.
Electromagnetic radiation with the matter, that is called as spectroscopy. But
Yes,
in correct. But in mass we use the term spectrometry. Why? Because there is no radiations or no electromagnetic
no
radiations
use of
involved.
radiation.
Yeah, there is no involvement of any electromagnetic radiations. Like for NMR we use radio waves, UV rays, etc. for UV. But for mass spectrometry we do not use any electromagnetic radiation. But for here we use the high energy electrons. That's why it is called as mass spectrometry instead of spectroscopy. And mass spectrometry helps us to find out about the molecular weight and the structure of the molecule. Like in IR, we used to find out the functional groups. In NMR, we used to find out the structure, like what are the like number of protons, number of carbons, and all. And but in mass spectrometry, it will tell about the molecular weight as well as the structure. So basically, in mass spectrometry, we use high energy electrons to break the molecules into the fragments. So basically, what are the steps involved or like instrumentation for the mass spectrometry? Firstly, you will inject a sample and there will be some hot plate on which you will inject the sample, and because of that it will vaporize. Suppose you have a sample M and you put into that hot plate, so it will convert into the gaseous forms or vapors. Then after vaporization it will further ionized, that there will be loss of an electron, that the molecule will be ionized. Then after ionization the molecules will fragment out, then it will be further accelerated, then after acceleration there will be the deflection, and then the different fragments of different mass will be separated and further detected by the detector. So this is the basic instrumentation of the mass spectrometry. I'm not going into detail as we have already discussed, learned in the like previous videos. So this is the basic steps, like firstly the sample will be injected, then it will vaporized, then further ionized, then fragmentation will be occur, then it will be accelerated followed by deflection, then it will be separated by according to the mass and further detected through the detector.
What is EMRX?
uh, can you please repeat? You know
What is EMRS? You have written on the first slide.
what is,
EMRS.
your voice is actually breaking.
EMRX. Yes,
Electromagnetic
yes.
radiation, it's not X, like I'm just like electromagnetic
Yes,
radiation,
yes,
that is
yes.
there is no electromagnetic radiation involved in mass. It's just cross, not X, it's just a cross, like no electromagnetic radiation involved.
Yes, yes. Okay.
Like X was just a cross. So basically in this mass we use the terms m by z value. M is the molecular mass and z is the charge. So there is a relation that m by z is directly proportional to the r square, that is a radius square, and it's directly proportional uh, to the r square and inversely proportional to deflection. So this is one question. Like there's different cations, and out of these you have to tell me which of the following will be deflected maximum. So if you are being provided with these cations or these ions, which of the following will be deflected maximum?
What is the second term because it is directly proportional
What
to L
is the
square or R square?
Rohit? Like what is the query? Like in the question you have to find out which ions will be deflected maximum. That you have to find. So we know this relation that m by z is inversely proportional to the deflection. So just take a look one by one. Like for 16 O2 plus m by z, m is the mass. So what is the mass for oxygen? So what?
16.
16. Since there are two oxygen here, so the mass will be 16 plus 16, that is 32. And what
32
is the charge here? Z. Z is plus 1. So m by z will be 32 by
plus 1.
1, that is 32. Now if you will take a look at 16O and 18O. So what will the m by z? As there is one oxygen of 16 mass and other oxygen of 18. So total mass is 34. So m by z here will be 34. Now if you will look upon 16O2 2 positive, then mass is 16 plus 16, that is 32. And what is charge here? Z is plus 2. So m by z will be 32 by 2, that is 16. Now if you will look 18O2 2 positive, in that case mass will be 18 plus 18, that is 36. Charge is 2, that means m by z is 36 by 2, that is 18. Since m by z is lowest for this molecule, it is 16. Like for the first one it is 32, for the second one it is 34, and for the third one, the 16O2 2 positive, it is 16, and for 18O2 2 positive it is 18. Since the third one,
Slide is not visible.
slide is not visible. Just a second. There is a network issue, I guess. Is it visible
Now
now?
visible.
So you were having the four options. 16O2 plus 16O18O, 16O2 2 positive and 18O2 2 positive, and the question was, out of these ions deflection will be maximum where? So you know that m by z is directly proportional to r square and inversely to deflection. So one by one we will calculate the m by z value. As there are two oxygen molecules so having 16 mass, so m will be 16 plus 16, that is 32. Charge here is 1, so m by z will be 32 by 1, that is 32. Now for the second, m will be 16 plus 18, that is 34. So m by z here is 34. Just calculate for the third one, the 16O2 2 positive. What will be the mass and the charge, that is m by z value?
32 by 2, that is 16.
Correct, it will be 16. And for the fourth one,
32 by 2, 18.
32 by 32. Now oxygen has mass
Sorry,
18.
30,
Correct,
34 by 2.
36 by 2. 18 plus 18 is 36. So 18. Since the m by z value of 16O2 2 positive is lowest, is 16. This is the lowest value. So as it is inversely proportional, so lowest m by z value means highest deflection, as they are inversely proportional. So the correct answer will be, so the correct answer will be the third one, the 16O2 2 positive, as it has the lowest m by z value. Is it clear? Is it clear?
Yes.
We will discuss some of the basics also, like for the mass, like in the mass spectrometry we generally obtain a graph between the intensity ratio and the m by z values. So like suppose you have to calculate the m and m plus 1 for TMS. So what will be the m and m plus 1 for TMS? M ratio m plus 1 value. Like just before solving, just tell me what is difference between the base peak and the molecular ion peak.
Molecular peak is that which have the highest M by Z ratio value.
Which has the highest peak?
Means highest peak, which have the M by Z ratio value highest.
Like the molecular peak means the which has the highest peak, like highest mass. The one which has the highest mass is the molecular ion peak, and the base peak is that peak which have a maximum intensity, whose intensity is 100%. That we call as base peak. that there is a difference between base peak and molecular ion peak. That molecular ion is that the highest peak which having a highest mass, but in base peak those peak in which the intensity is 100%. Like suppose if one peak is this, like other peaks are this, and suppose it is T100 and 500. So this peak, as the intensity is maximum here, so this peak will be your base peak, who is having intensity of 100%. And since in all the peaks the mass is 500 is the highest mass here, this will be your molecular peak. Is it clear?
Yes, ma'am.
Okay. So now we have to calculate the ratio of m and m plus 1 for the TMS. TMS, you know, we studied NMR that TMS is, what is the full form of TMS?
Tetramethyl silicate.
Silane.
Silicon.
So they will tetramethyl silane. Now you know that carbon can exist in two forms. It can be exist as 12C or it can be exist as different isotope, that is 13C. And the abundance or the natural abundance for 12C is 97.5% and for 13C it is 1.1%. Similarly, the silicon. It can exist in nature in as 28 Si, 29 silicon with 30 mass. And the natural abundance will be 100% for this one, 5.1% and 3.4%. Is it clear? This you have to remember, like what are the natural abundance of some of the isotopes. Like for the hydrogen, carbon, silicon, maybe it will be given the question, but carbon, hydrogen you must know. Like carbon may exist as 12C or 13C. In 12C it is 97.5%, whereas in 13C it is 1.1%. Is it clear?
Yes, ma'am.
Okay. Now suppose I am asking you to calculate m ratio m plus 1 and m plus 2 also for this system. M, you know, like if some system has a mass of 70, suppose, so m plus 1 will be 70 plus 1, that will be 71. Now I am asking about the tetramethyl silane. The TMS value m, m plus 1 and m plus 2. Suppose you are telling that the m is almost 100%. So what will be the m plus 1? Like you know, in tetramethyl silane you have a silicon, carbon and hydrogen. And for the abundance of 12C is 1.1, 13C it is 13C it is 1.1, 12C it is 97.5%. Similarly for silicon it is 100% for 28, and for 29 it is 5.1%, and for 30 silicon it is 3.4%. Now m plus 1. M plus 1 means, firstly, let's talk about carbon. There are 4 carbons, and simply m means which is 100%. Like it can be 28 silicon here, and in m plus 1 there will be 29 silicon. So the natural abundance of 29 silicon is 5.1%. So as there is 1 silicon, you multiply by 1 into 5.1 plus for the 4 carbons. Like carbon can exist at 12C and 13C. So m plus 1 contains 13C. It will be 1.1. So you will multiply 4 into 1.1 plus hydrogens. You have 3 plus 3 plus 3 plus 3, that is 12. And you know proton can exist in both 1H and 2H form. Deuterium. Tritium is also there, but the natural abundance of tritium is very less, so we will neglect that. So for deuterium, the natural abundance is 0.015%. So after solving it, the m plus 1 will come out to be 9.68%. Is it clear? Or should I repeat?
Ma'am, why you are taking a natural element which is less one?
See, there are basically two peaks. Like, firstly, we are calculating the ratio of m plus 1, and m plus 2. So for m, that is molecular ion m, we are considering m as 100%. So like carbon can exist as 12C and 13C. 12C 97.5% and 13C is 1.1%. So firstly we are taking 12C as 100%. So in M form there only exists the 12C, that is 100%. But now if you will see the molecule M plus 1, so it may contain 13C also. So for the TMS, as you have 4 carbons, 12 hydrogen and 1 silicon. So for 4 carbons, as the 13C has 1.1% natural abundance, so we will multiply by 4. Similarly, you have 12 hydrogens, and for hydrogen 1H it's nearly 100%, and for 2H it's 0.015%. So we multiply by 0.015. Then for silicon it can be exist in 3 forms: 28, 29, 30 masses. So 28 mass you are considering as 100%. So for 29 silicon, you should multiply it by 5.1, and as silicon is 1, so you will multiply by 1. So m plus 1 will be 9.68%. Now if you will look for m plus 2, so in m plus 2 you will consider only 30 silicon 1. So it will be 1 into 3.4%, that will be 3.4. So for m plus 1, m plus 2, it comes out to be 100. For m plus 1 it was 9.68, and for m plus 2 it was 3.4. So for calculating the exact ratio, you can simply multiply by 3.4, 9.68 divided by 3.4, 3.4 divided by 3.4. So the ratio will be 30 ratio 3 ratio 1. This will be exact ratio for the m plus 1 and m plus 2. Is it clear?
Yes, ma'am.
Maybe we will solve some more examples, then it will be much more clear to you. Let's simply take about C6H6. So you have to calculate the ratio of M and M plus 1. Now we are considering M as 100%. 100% means it contains 12C and 1H. So now we want to know for M plus 1. So now carbon will be in 13C form and proton in the 2H form. So since you have having 6 carbons, and what is the natural abundance for 13C? It is 1.1 plus hydrogens is 6, and for deuterium the natural abundance is 0.015%. So the answer will be 6.6 plus 6 into 0.015, so that will be 6.69 approx, 6.69%. So M ratio M plus 1, 100 hundreds to 6.69. So 100 divided by 6.69, ratio 6.69, ratio 6.69. So the answer will be 15 ratio 1. As in nature there can be different isotopes, so carbon can exist as 12C and 13C. So we are considering the abundance of 12C, it is 97.5, so we are considering it almost 100%. So in M there are 12C, but if we are considering M plus 1, then there may exist the carbon in the form of 13C. Since the 13C has 1.1 natural abundance, so we will solve according to that. Because if you will consider 97.5%, then also answer will be nearly same. Is it clear?
It means, yes, it means, in case of addition of one in weight, then you have to use according to that isotope there.
Actually, your voice is not clearly audible. Like, can you repeat it again?
Hello,
Yes.
hello. I'm telling that in case of M plus one, you are telling that
In place of?
you have to use in case of calculating M plus one.
Okay.
M plus one, there will be that isotope of atom will be used, which has addition of one in their
Yes, addition
uh,
isotope. Correct. Additional.
molecular mass.
Yes, correct.
Addition of one in their molecular mass or
Yes, correct.
atomic weight. No?
Correct.
And hence, in case of M plus one, you are using particular that isotope, and in case of M plus two, using
Correct.
particularly that
That has a mass of
isotope which has
plus 2. Yes, they will be
addition of plus two is there, right?
correct.
Yes, I have that. And that was the
Hmm,
conclusion.
correct.
Now it's
Now just tell me for the anthracene. What will be the M, M plus 1 and M plus 2? Like anthracene, it will be C14H10. So what will be the ratio of M, M plus 1 and M plus 2 here? Basically, like in carbon, carbon can exist as two isotopes, 12C and 13C. 13 is what? Like 12 plus 1, M plus 1. So M plus 1 is that mass which have additional mass of plus 1. and plus 2, that additional mass of plus 2. Like in case of silicon, 28 silicon, 30 silicon, then there is difference between the two mass, that is m plus 2. Now just tell about anthracene. It is C14H10. So what will be the ratio of m plus 1 and m plus 2? Rohit, Kartike, Arpita, anyone? So first tell me what is m. You are considering as m as
When M will be the 100%.
correct. Like m is the 100%. And what about m plus 1?
25.35.
20. No, it's wrong. Just tell me like one by one. For m plus 1, what will be the value? Like how you will solve it?
14 into 1.8.
14 into 14 into.
1.8.
No, it's 1.1, not 1.8. It's 1.1. The abundance of the carbon is 1.1. It's not 1.8. 13C exists as 1.1%. And then you have to plus for the hydrogen also, like there are 10 hydrogens. So for 10 into, so what will the natural abundance for deuterium? It will be 0.015%. Therefore, after solving it, it will be 15.55%. Is it clear?
Yes, ma'am.
So just tell me for m plus 2. What will be the answer for m plus 2? There is one formula also, like by which you can easily calculate m plus 2. Just remember this, it will be 0.006 into n square, where n is your number of carbons. So 0.006 into n, and n here is 14. So after solving it, it will be 1.176. So if you will calculate the ratio of m plus 1 and m plus 2, it will be 100 ratio 15.55 ratio 1.176. So that will be 100 ratio 15 ratio 1. Is it clear?
But my carbon M plus 2 mean its radioactivity is not exist. Means 12 and 14, 12 and 13 exist. So when M plus 2, how can we go for carbon?
Like for longer, just remember, like for the longer systems, like if you are considering longer like longer molecules having longer chain or something like that, having high number of carbons, then you will use this formula 0.006 into 10 into n raised to power square. Like for tritium, like for carbon and hydrogen, we can it can exist in both forms. Like for hydrogen, you can go for tritium, but we can't consider tritium. Why? Because in case of tritium, its natural abundance is very low. So we will not consider that. But we can go for m+2 for carbon. And to solve it, we can use simply this formula 0.006 into n square. For carbon we can go, but Venice is low, but we can calculate it. Like you can, like, we will discuss further also, like for halogens also. You can go to any, like it can be m+1, it can be m+2, it can be m+3.
Voice is break. Voice is break.
Am I audible? Hello?
Yes, ma'am.
Now audible.
Yes, ma'am. You are audible.
So I'm telling we can go to any value, like we can go to m+3, m+4. Like we will discuss for halogens also. In halogens the difference is of +2. So we can go to m+2, m+4, m+6. It will depend on the number of halogens. We will discuss further also about this. So there can be any peak. So just to calculate m+2, you can use directly this formula 0.06 into n square. Like just simply you can take another example, fullerene. Fullerene is C60. You have to calculate m+1 and m+2. So what will the value? Like what is m+1, m+2? M is simple, the mass. If the mass is 70, m+1 means 70 plus 1 mass. You're adding one more mass to it. And m+2, you're adding simply two more mass to it. So for C60 fullerene, what will the m+1 and m+2?
Will be 720.
What? 720? Carbon can exist 12C and 13C. So you are considering m, that the carbons are existing in the 12C form. So it is nearly 100%. The natural abundance is 100%. And then here we
100%, then 66%, then 21.6%.
correct. So final ratio will be just divided by the lowest number, 21.6, ratio 66 divided by 21.6, ratio 21.6 divided by 21.6. So after solving it, it will be 5:3:1. Is it clear?
Please repeat.
See, for fullerene, you have to calculate m+1 and m+2. What is m+1? M+1 is that molecular ion which has a mass number of 1 higher than m, and m+2 is that whose mass is 2 times like it's 2 higher than the m. Now consider m as 100%. So what will be the m+1? Now in this carbon will exist in the 13C form. So 13C has natural abundance of 1.1 and you have a 60 carbons. So we multiply by 60. Uh, so 1.1% into 60 is 66%. So m plus 1 is 66. Now to calculate m plus 2, just simply use this formula 0.006 into n square. N is 60, so 0.006 into 60 whole square. So the value will be 21.6%. Now for the ratio, 100 ratio 66 ratio 21.6, it will turn out to be 5 ratio 3 ratio 1. Is it clear? So just remember, like,
Can you go back to previous slide?
yes, maybe I will explain it again. Just remember, firstly you have to remember like what is the natural abundance of different isotopes. For 12C it is 97.5%. For 13C it is 1.1%. For carbon, for hydrogen you can consider it is 100%. For deuterium you can consider it as 0.015%. Is it clear? Like for silicon it is 28 silicon it is 100%, nearly 29 silicon it is 5.1%, 30 silicon it is 3.4%. And for chlorine, if you are considering, chlorine exists at 35 and 37. 37 it is 75%, and for 37 mass chlorine it is 25%. And like for bromine, it may exist 79 Br and 81. For 79 it is nearly 100%, and for 81 mass of bromine it is 97.5%. Is it clear? This you have to remember. Like these are some common natural abundance of isotopes of different elements. Is this like up to the like this slide it is clear?
Voice is breaking and slide is
Yes, ma'am. Slides are not
I don't know
which
why
you
there is
written.
so
It's
much of
not clear.
network issue. Now it is visible. Now it is visible.
Yes, ma'am.
Hmm. So just remember from this slide what is the natural abundance of different isotopes of the elements. Like for carbon it may exist as 12 and 13C form. In 12C it is 97.5%, in 13C it is 1.1%. Similarly from proton, like for 1H it's nearly 100%. For deuterium it's 0.015%. Similarly for silicon, chlorine and bromine, these are generally asked elements. And for like bromine, 81 bromine and 12C, it's approx 100% only. So you may consider it to be 100% also, because they will not make any much difference. Just remember, like for 13C 1.1, for deuterium 0.015.
ma'am.
Is it clear?
Hello, hello.
Yes.
Yes, ma'am. There is one question that in case of carbon, there is a 13, 12C and 13C. You can calculate M
But
plus
your voice is
M
not
and M plus
coming.
1. Hello,
Hello?
is it audible?
Yes. Actually, there's some
Hello.
background noises.
Yes, yes. I am telling that in case of carbon, there are two isotopes. So there will be M and N plus 1.
Your voice is not audible at all. Can you just type in the chat box or like actually there is some background noise that is coming along with your voice. Rohit? Rohit?
Yes, ma'am.
Yeah. Just tell me the question.
Hello. Hello.
Yeah, you are audible.
I'm telling that yes, yes. I'm telling that in case of carbon, there are two isotopes, right? So there will be one.
In carbon there are two isotopes. Yeah. Then
One is carbon 12 and other is carbon 13.
correct.
So in case of carbon 13, then we will use carbon 13 in case of M plus 1
Yes.
while calculating. And in case of hydrogen, we use deuterium in place of for calculating M plus 1.
Like see, basically there are two isotopes of carbon, 12C and 13C. 13C is just one addition of the 12C. Like 12 plus 1 is 13. So if you consider the molecular and M as 100%, that means you're considering that all the carbons are existing in the 12C form. But now if you are considering the molecular ion as M plus 1, that is one additional extra mass. That means in that case all the carbons are existing in the form of 13C, as it is M plus 1, 12 plus 1. So now you're considering the carbon to be existing in the 13C form. Similarly for the hydrogen, like there can be three isotopes for hydrogen: protium, deuterium and tritium. Like 1H. 1H you considering as M. Similarly, if for deuterium it is 2, mass number 2. That means M plus 1, that is 1 plus 1. So M plus 1 is deuterium. And if you will consider M plus 2, then it will be tritium. But since in case of tritium, the natural abundance is too low, so we just generally neglect it. Now it is clear.
Yes, ma'am. Now it's clear. But once again, one doubt is there in case of chlorine and bromine. In case of chlorine, there is a natural abundance of chlorine 35 is 75%, chlorine 37 is 25%. But when we will use chlorine in case of M plus 2, right?
Like for fluorine you are asking F.
Chlorine and bromine. Now. In case of chlorine and bromine, I'm asking
In
about
case
that
of
when
in case of
chlorine, Cl,
acha
chlorine.
chlorine, yes.
Yes, yes. In case of chlorine, I'm asking that in case of chlorine, when carbon chlorine 37 will be used
Okay.
for calculating M plus 1 or M plus 2.
Actually, chlorine in chlorine case is different. In chlorine, there can be existing in the two forms. It can be 35Cl or 37Cl, and the abundance is not 100% for like anyone. It's 75% for 35, and for 37 it is 25%. So you have to consider both. Like I will explain it also. Like we will discuss about halogens also.
Yes, yes, yes. Since there is no not 100%, hence I'm getting
Yeah, we will
confused with
discuss
that.
it
How?
also.
Yes, yes. How can we use?
Like up to like carbon, hydrogen, silicon, etc. It is clear.
Yes, ma'am. It's clear.
Okay. So suppose you are considering that there are two halogens, like two chlorine is present in your system. So just remember that the number of halogens will be equal to the number of isotopic signals. Since the halogens are two, like chlorine is two here now, so there will be two isotopic signals. And in halogens case, the difference is of 2 plus 2. Like in earlier for carbon and hydrogen, we were considering m plus 1. So difference was 1. But for halogens, the difference will be in case of plus 2. So it will be m plus 2, m plus 4, m plus 6, m plus 8 and so on. So since there are two chlorine, that means there are two halogens. So the isotopic signals will be 2. So for m, one isotopic signal will be m plus 2 and other will be m plus 4. Since there are two halogens, so there will be two isotopic signals, that is m plus 2 and m plus 4. Is it clear? Now if you will see about m, now you know chlorine can exist as 35 and 37 respectively, and 35Cl it is 75% and 37 it is 25%. So now for the molecular m, so you have two chlorines, so both chlorine will be existing in the form of 35. Now for m plus 2, there can be possibility that one chlorine is 35, another is 37. Or there can be one possibility that the first chlorine is 37 and the second chlorine is of 35. Similarly for m plus 4. M plus 4 means both the chlorines will be of 37 atomic mass. Is it clear? Rohit?
Yes, ma'am. But in case of this four, uh,
Like similarly,
how
like
we are
if you're
taking
taking a chlorine, na,
fluorine.
like how we can say, like see there are 35Cl and 37.
Yes,
So the first one it is existing in the form of 75% and another is 25%. So calculate the ratio. Like if you're considering this 37Cl as 100%, so how you will calculate for the
yes,
35 one? It will be 75 divided by 25 and into 100. So it will be 300. So 300 ratio 100, it will be 3 ratio 1. Now if you will look upon this m value, this m is 30, like both the chlorines are having mass of 35. That means 35 is 3 ratio 3 now. So it will be 3 into 3, that is 9. Now for m plus 2, like for first chlorine it is 3 and for the second chlorine it is 1. Similarly for 37, 35 it will be 1 into 3, that is 3 plus 3, that is 6. Similarly for m plus 4 it will be 1 into 1, that is 1. So the ratio will be 9 ratio 6 ratio 1. If you are having two chlorines, the ratio of intensity will be 9 ratio 6 ratio 1. Now it is clear.
yes, ma'am.
Okay. Maybe we will solve one of like one or maybe two three examples more so that it can be furthermore clear. Suppose you are having three chlorine in your system, then you have to calculate the ratio of m. Like now you know three chlorine means there are three halogens, so there will be three isotopic signals, m plus 2, m plus 4 and m plus 6. So M means you are having all the three chlorines in the form of 35. And M plus 2 means in the three chlorines, one can be 35, other two can be 37. Or there can be a chance like the first and second are 37 and the last one is 35. Or there can be chance first and last is 37 and the middle one is 35. Similarly for M plus 4, there can be chance that there will be two chlorine of 37, one of 35. Oh, this we have wrong written. 35, 35, 37, and 35, 35, and then I will write it again maybe. Like 37, 35, 35, 35, 35, 37, 35, 37, 35. Similarly for M plus 4, it can be 37, 37, 35, 37, 37, 35, 35, 37, 37. So for the M, like 35 chlorine has 3 ratio na, so 3 into 3 into 3, that will be 9. Ratio 9 into 3, that is 27. Similarly for this one, it will be 1 into 3 into 3, 1 into 3 into 3 plus for this one it will be 3 into 3 into 1 plus for this one it will be 3 into 1 into 3. So it will come out to be 27. 9 plus 9 plus 9, that will be 27. Now here it will be for this one, here it will be 1 into 1 into 3 plus for this one it will be 1 into 3 into 1 plus for this one it will be 3 into 1 into 1 into 1. So it will be 3 plus 3 plus 3, 9. Similarly for M plus 6, if you calculate, it will be 1. So the ratio will be 27 ratio 27 ratio 9 ratio 1. Is it clear? Is it clear? Now it is clear to everyone?
I'm not getting how we are doing.
Yes, not getting how
Oh,
you distributed that.
like up to this it was clear, like for carbon hydrogen one if we were calculating, like for fullerene and all, it was clear.
Yes, ma'am.
Okay.
How you're dealing with chlorine, ma'am?
Like
Not
for
getting.
halogens you're not getting. Okay. See, if you're considering for the halogens, suppose I am telling you like for the two chlorines, so as number of halogens are 2, so isotopic signals will be 2. Now if for M, isotopic signals will be 2, one is M plus 2 and other will be M plus 4. Like in halogens the difference in the mass is of 2, So if you are considering isotopic signals, so it will be m plus 2, m plus 4, m plus 6, m plus 8, so on. Since there are two chlorines, so there will be two isotopic signals, that is m plus 2 and m plus 4. Up to this it is clear?
Yes, ma'am.
Okay. So now chlorine can exist as 35 and 37 form. And the abundance of 35 is 75%, and for the 37 it is 25%. Is it fine?
Yes.
Now for the m1 means the highest one, which has the highest abundance, so it is 35 cl. So both the chlorine will be of 35, like both the chlorine will exist in the form of 35 for the m1. Like now you're considering m plus 2. So in m plus 2 there can be both chlorine, it can be 35 or it can be 37. So it can be possibility that the first chlorine is existing in the form of 35 and the second chlorine will exist in the form of 37. Similarly, it can be possible that the first chlorine is in 37 form and the second chlorine is in the form of 35. Now if you look for the another isotopic signal, that is m plus 4. In m plus 4 means both the chlorine will exist in the form of 37 and there will be no 35 chlorine present. Now if you will just calculate the ratio of 35 C chlorine, so if you are considering the 37 chlorine, this one as 100%, like this chlorine you are considering as 100%. So for the 35 Cl it will be 75 divided by 25 into 100, that will come out with 300%. So 300 ratio 100, that is 3 ratio 1. So your 35 chlorine is 3 times than the 37 chlorine. So see here, like in the M, both the chlorines are 35 in nature. So ratio is 3 for this one, it is 3. So 3 multiplied by 3, that is 9. Now for M plus 2, for 35 Cl it was 3 and for 37 Cl it was 1. 3 into 3 it is 3. But there is another chance that the first chlorine will be 37 and the second will be 35. So just plus, for 37 it is 1 and for 35 it is 3. So 3 plus 3 is 9. Sorry, 3 plus 3 is 6. Now for 37, both the chlorines are 37 and the ratio is 1. So 1 into 1 it is 1. So the answer will be 9 ratio 6 ratio 1. Now it is clear.
Yes, ma'am. Got it.
Now if you will just see about 3 chlorines. If you are having 3 chlorines, 3 means halogens are 3. Therefore 3 means isotopic signals will be 3. So first signal is m plus 2, second is m plus 4, third is m plus 6. So m means all the chlorine will be in the form of 35 one. Second one means one of the chlorine will be in the another 37 form. M plus form means two chlorines will be 37 one. M plus 6 means three chlorines will be in 37 form. Now it is clear.
It means as we go from M to M plus 1, M plus 4, M plus 6,
Huh.
the
Like there are two
less
chlorine.
abundant, less abundant chlorine is.
Huh. See, 35 has the natural abundance highest, so all will be M. All will be existing in the 35 form in M. M plus 2, that means 1 will be 37, the second isotope, and rest others will be 35. M plus 4 means 2 will be in another form and 1 will be 35. M plus 6 means all the chlorines will be in the second isotopic form, that is 37. Like see here, for the M, all are 35. In M plus 2, only 2 are 35, 1 we have replaced to 37. M plus 4 means Like M plus 4 is the second isotopic signal, means in second isotopic signal means 2 chlorines have been replaced to 37. M plus 6 is the third isotopic signal, means all the 3 have been replaced with the another isotopic, that is 37. Now it is clear. See, maybe I will write it again. See there, we are talking about 3 chlorine, means M plus 1, M plus 2, sorry, M plus 2, M plus 4 and M plus 6. So basically these 3 are the isotopic signals. Is it clear?
Yes, ma'am.
So see, like we are having 3 chlorines, like 3 chlorine here in M. 3 chlorine is in the M, it means all are in the 35 form, as 35 as the highest abundance. It is 75 and the 37 chlorine has 25. M plus 2 means only one chlorine you have replaced 37, rest others are 35. Is it fine? M plus 4 means 2 chlorines you are replaced by 37 and 1 is 35. M plus 6 means you have replaced all 3 chlorines by 37. Now it is fine. Like for M, all are
Yes, ma'am.
existing in 35. M plus 2, you have replaced only 1 chlorine to 37. M plus 4 means you have replaced 2 chlorine with 37. M plus 6 means you have replaced the 3 chlorines with 37. Now it is clear?
Ma'am, why you are taking that 37 CL as a 100%, considering that 100%?
We are not taking 37 as 100%. We are taking 35 as 75 and 37 as 25%. But 35 chlorine has more natural abundance. It occurs in 75%. We are not considering any isotope of chlorine as 100. We are considering 35 Cl as 75%, 37 Cl as 25%. So abundance of 35 is more. So we are considering M as 35 one. Now it is clear? Earlier what were you were taking? Like you were taking natural abundance of that which is 100%, like in hydrogen, 1H. But in 35 and 37, if you will compare, natural abundance of 35 is more. So you are considering M as 35. And with each isotopic signals, we are replacing that atom with the another isotopic signal. Like for M plus 2, it's the first isotopic signal. So you replace only one chlorine. M plus 4, it is the second isotopic signal. So you are replacing 2 chlorines. M plus 6, it is the third isotopic signal. So you are replacing the 3 chlorine atoms. Is it clear?
Yes.
So see here M plus 2. Now there can be like now you're like there are 3 chlorines, this one, this one, this one, but you are replacing the first one. So there can be possibility that the second one is replaced. There can also be possibility that the third one is replaced. Rest others can be same. Similarly in this case, M plus 4 you were replacing by 2 chlorines. So it can be that first and third chlorine is replaced, or second and third chlorine is replaced. So that can be these chances also. So now for C, for M, 35 Cl, 35 the intensity is 3, multiply by, for the second chlorine it's 3, for the third chlorine it is 3. So 3 into 3 into 3 it's 27. Now for M plus 2 for this one, the first one, it's 35, 37, 35, 35. Intensity of 37 is 1, 35 is 3, 35 is 3. Then for the second one you will add plus 35 it is 35, 37, 35. 35 it is 3, 37 it is 1, 35 it is 3 plus for this 35, 35, 37. It's 3 into 3 plus 1. That will come out to be 9. Similarly, if you will solve this, m plus 4 1, it will be 27. 9 plus 9 plus 9. So after solving this, it will be 37, 37, 35. So 1 into 1 into 3 plus 1 into 3 into 1 plus 3 into 1 into 1. That will be 3 plus 3 plus 3, that is 9. Similarly, for 37, it will be 1 into 1 into 1, that is 9. So the ratio will be 27, ratio 27, ratio 9, ratio 9. Is it clear now?
And last one will be 3, na? All will be 37.
So
So
37 is 1,
1
na?
into 1.
37 is 1. 35 is 3. 37 is 1.
And then, so total will become 3, na? 1 into 1 into 1 plus again 1 into 1 into 1. Na? All total
No, no,
outcomes will
no.
be 1.
Like, see,
1 into
it has only one possibility, 37, 37, 37. For 37, it is 1. For the second 37, it is 1. For third 37, it is 1. This is how we are calculating now. Plus, we are using for this one, m plus 2 and m plus 4, since there are two more possibilities. So, for the second possibility, we are adding this plus sign. For third, we are adding this sign. Is it clear?
yes, ma'am.
It will be more clear. Like, I will just take an example of bromine. For the bromine one. See, bromine can exist in two forms, 79 and 81. And 79 bromine exist in 100% and the 81 exists in the form of 97.5. So now also you will consider it as 100%. So 100 ratio 100, that is, it is 1 ratio 1 only. Like for chlorine it was 3 ratio 1. So for bromine it is 1 ratio 1. So it's nearly same. Suppose you are having two bromines. Two bromines means there will be two isotopic signals involved. That means M, first isotopic signal M plus 1, second signal M plus 4. Now see M. Now you know bromine M. M means natural abundance was high for the 79. Na? So in M all the bromine will be of 79 1. Is it clear? Now M plus 1. M plus 1 it is your first isotopic signal, this one. So in this only one bromine will be replaced by 81. So 79, 81. There can be chance that the first one is replaced by 81. Now for M plus 4. M plus 4 is the second isotopic signal. That means both the bromine will be replaced by 81. Is it clear now?
Yes, ma'am.
Hmm. So see here for M. It's 79, 79. 79 is 1. 1 into 1 is 1. For M plus 1. Firstly 79, 81. It's 1 into 1 plus, as there was another possibility, 81, 79. It is 1 into 1. That is 1 here, 2 here. And M plus 4, 81, 81. 1 into 1. That is 1. That is 1. So the ratio will be 1, ratio 2, ratio 1. Now just tell me for, in case if you are having 3 bromines. 3 bromines means how many isotopic signals you are having?
3.
3. And what are those signals? M. For M, what are the isotopic signals? M plus 2. Just tell. It will be M plus 4 and M plus 6. These will be the 3 isotopic signals. Is it fine?
Yes.
So now for M. what will be the bromine like? In which form it will exist? All the three bromines will exist in which form?
79 dear
79.
something.
Now M plus 2. M plus 2. In which form bromine will exist?
Both 79 and 81.
179 and 181. And third one in? Third one chlorine. There are three bromines now. So third bromine
79. 79.
79. But there can another possibility also. What will the possibility? You have replaced the second one. Now you can replace the first one also now. If you are replacing the first bromine to 81, rest others will be 79. Or you can replace the third bromine with the 81 and rest others will be 79. So there can be possibility of 3 in M plus 2. Is it fine? Is it fine?
Yes.
Hmm. Now M plus 4. In M plus 4, what will be the isotopes? Like in which form it will exist? M plus 4.
79, 81, 81.
Correct. 79, 81, 81. But there will be another possibility. What will be that?
81, 81, 79.
One more possibility can be there. What will it be?
81, 79, 81.
81, 79, 81.
81.
And in M plus 6? M plus 6.
81, 81, 81.
Correct. Now the solve it for M. What will the ratio like? For 79 it is 1. Like for bromine, whether it is 79, whether it is 81. It is 1 only. So 1 into 1 into 1. That will be 1. And M plus 2. Well, like in M plus 2. What it will be?
3.
3. Correct. And M plus 4.
3.
And M plus 6. M plus 6. M plus 6. Hello? 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 Am I audible? Hello?
You can hear you, man.
Hello? Am I audible?
Yes, audible.
So in M plus 6, what it will be? M plus 6.
Hello.
Hello? Yeah, you're audible.
How is this?
M plus 6.
Mm,
Like M it is 1, M plus 2 it is 3, M plus 4 it is 3, and M plus 6 it will be.
How it is 3 in case of m plus 2 and m plus 4?
Like see here in the slide, there are three possibilities for M plus 2: 79, 81, 79, 81, 79, 79, and 79, 79, 81. So let's talk about the first one. It's 1 into 1 into 1. For the second one, it will be 1 into 1 into 1. For third one, it will be 1 into 1 into 1. So 1 plus 1 plus 1. It will be 3. Is it fine? Rohit?
Yes, it's clear.
Okay, then tell me about M plus 6. M plus 6.
1.
Correct, 1. So the ratio will be 1 ratio 3 ratio 3 ratio 1. Now it is clear? Now it is clear?
Ma'am, can you go to previous slide, that
Yeah.
chlorine one?
Yes.
Ma'am, M plus 6, ma'am, how it is, ma'am, 9?
Oh, it's 1. It's not 9. It's 1. 1 into 1 into 1. It's 1 now.
I'm not getting that 9, ma'am. How it's coming?
It's
So,
1. It's 1. M plus 4 is 9. M plus 6 is 1.
okay, okay.
Yeah. Actually, it is 1 only, but it's looking like 9. Yeah. Like up to this, it is clear. Like, is there any doubts?
Yes, ma'am. No, ma'am.
Okay. So let's solve some questions. So in the question, the mass spectrum of 2-pentene exhibits prominent peak at M by E70. Before that, there is one more question. This one. Explain the formation of the prominent ion peaks at 72, 71, 57, and 43 in the mass spectrum of 2-methyl butane. This one. Indicate the ion responsible for the base peak. Now you are providing that the M by Z values are coming to be 72, 71, 57, and 43 for the 2-methyl butane. So let's look on the fragmentation pattern. Like how can the mass by charge ratio to 72, 71, 57, 43. So let's about 2-methyl butane. So the structure of 2-methyl butane is CH3, CH2, CH, CH3, CH3. Is it fine? So now you know
Yes, ma'am.
that it is ionized. So there will be formation of radical cation, and if you will see the M by Z here, it is 72. Like 1, 2, 3, 4, 5. Carbon 5, hydrogen is 3, 4, 6, 5, 6, 7, 9, 10, 11, 12. So after solving it, the m by z will be 72. Now, if one of the electron is removed, then it will comes out to be 71. After formation of radical cation, it will be 71. Now highest value 72, it indicates that the molecular mass is 72. 71 means one electron is removed. Therefore it is 71. Now how come 57 and 43 will come? And 71 will come. So you have to remove one one proton radical. Like if you will remove one hydrogen radical from here, like CH3, CH2, C, CH3, CH3. So as here you are having one CH now here. Like here you have having one hydrogen. It means this, like it looks like this. So if you will remove one electron, then there will be radical cation formation like this, and hydrogen radical you are removing. So now the mass will be 71. Now for the second possibility can be you are removing the methyl radical. Then it can be CH3, CH2, CH, CH3. Then the mass by E value will be 57. Another possibility is that you are removing the ethyl radical. CH3, CH2 radical. Like this radical. Then it will be CH, CH3, CH3 radical. Sorry, cation. The mass by Z value is 43. It's erased maybe. See, 2-methylbutane is having molecular mass 72 as it is indicated. So if you will remove, like firstly how you will decide like which of the molecule, like which fragment or which element you have to remove. Those who are loosely bound will remove. Like firstly there is a possibility that non-bonding electrons, that is lone pair, will be removed. Then pi electrons are removed. Then sigma, because sigma is the strongest, so it is difficult to remove. So remember the order. Like firstly you will remove the non-bonding electron, then pi electron, then sigma electron. Since there are no pi electrons and no non-bonding electrons, you have to remove the sigma electrons. So the first case is that you can remove one hydrogen radical, this one. So it can be possibility like CH3, CH2, CH, CH3, CH3. It is formed. Another possibility is that you can simply remove the methyl radical, this one. So it can be CH3, CH2, CH, CH3. Another possibility that you can remove the ethyl radical. Then it can be CH, CH3, CH3. So if you will calculate the m by E value, m by Z value of this, it will be 71. For this it will be 57, and for this it will be 43. This is what it is asked in the question. Is it clear? Is it clear to
Yes,
everyone?
ma'am.
So suppose if your question is this, the mass spectrum of 2-pentene exhibits peak at 70, 55, 41, 39, 29, 27. Now from the question itself, it is clear that for the 2-pentene, the molecular mass is 70. CH3, CH2, CH, double bond, CH, CH. This is your structure of 2-pentene. And it's clear that M by Z is 70. Now you have to fragment in such a way that M by Z is 55, 71, 55, 41, 39, 29 and 27. So just fragment it. First fragmentation we can do by removing the methyl radical, this one. So it can be CH2, CH, double bond CH, CH3, cation and methyl radical is removed. So if you will solve this, M by Z comes out to be 55. Because Z is 1 or like it is plus 1 now, so Z is always 1. So we have to consider mass only. So it's 55. Now one more possibility is there. We can remove the ethyl radical, this one. So it can be CH, double bond CH, CH3. So then now the mass is 41. And from here, if we remove the two hydrogens, then it can be mass is 39. Now 39, 41 and 55 we know. Now we have to calculate 29 and 27. So if we are removing this one, then it will be CH3, CH2 cation plus CH, double bond CH, CH3 radical. So for this M by Z is 29. And from here, if we are removing two hydrogens, then it will be CH3 double bond, like if you are removing one hydrogen, then it will be two hydrogens, then it will be 27 mass. So this is how fragmentation is there in this case. Is it clear? Is it clear?
It will be CH2 double bond CH.
CH2 double bond CH, yeah. Is it clear like how we have fragmented? Because like see here in the question there are
Yes, ma'am.
no non-bonding electrons, no. So we can remove pi electrons and sigma electrons. And there were possibility like different possibilities, like it can be methyl radical, it can be ethyl radical. So we have to see all the possibilities and then we have to calculate the M by Z values. Is it fine? Now next question, how will you distinguish 3-methyl cyclohexene and 4-methyl cyclohexene using mass spectroscopy? So if you will see the structure, 3-methyl cyclohexene it's like this, and for 4-methyl cyclohexene it's like this. So now here how you will distinguish using mass? You know Diels-Alder cycloaddition reaction. Then it will be fragmented in this manner, that a dynein form. And if you will look for the 4-methyl cyclohexane, then this kind of structure will be formed. So if you will look upon this, then the M by Z value comes out to be 68. In case of 4-methyl cyclohexane, the M by Z is 54. So in this manner, after fragmentation, you can distinguish using mass. Because after fragmentation, the M by Z value will be 54 for 4-methyl cyclohexene, and for 3-methyl cyclohexene, it will be 68. Is it clear? Is it clear?
Can you repeat it?
Like see, oh, it is not erased. See, in the question they are asking, you have to differentiate 3-methyl cyclohexene. This is 3-methyl cyclohexene and this is 4-methyl cyclohexene. So how you will distinguish using mass? By fragmentation, like M by Z values will be different. See, you can break this in this format, na? The D-cellulose reaction, a dyne and dinophile is formed. Similarly, for this case, you can break in this form. And M by Z for this and this will be different. Here M by Z is 68, here M by Z is 54. Is it clear?
Okay. Yes, ma'am.
Yes. Now the next question. Outline the mode of fragmentation leading to the ions causing peaks as indicated by M by Z in the mass spectra. Pentanoic acid. See, this is structure of pentanoic acid. It is COH, CH2, 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 CH3. This is your pentanoic acid. Now you have to fragment it. As in this, you are having the gamma hydrogen and there is a possibility of McLufty rearrangement. Whenever you are having some gamma hydrogen, like the next, like see, if there is a carbonyl. So this carbon is alpha, this is beta, and this is gamma. If gamma hydrogen is present, so you can easily do McLufty rearrangement by removal of this. So there will be rearrangement of the gamma hydrogen, like here instead of CH2, just simply write CH2 here. So this gamma hydrogen can be easily taken by this. Then there is rearrangement in the double bond, and this bond goes to this. Then there is formation of OH, C, double bond C, H2 and OH positive, because this have taken this hydrogen. So here the fragment that will be formed will having mass of 60. That is what they are asking. Like in pentanoic acid, a fragment is formed with having mass of 60. So how it is formed? It is formed through McLufty rearrangement by rearrangement of the gamma hydrogen. As the gamma hydrogen is taken by the carboxylic acid, the oxygen of the carboxylic acid, then there is rearrangement. Is it fine? Now second is phenitone. Like this is the structure of phenitone. Now you have to fragment in such a way that the mass should be 94. Then how you have fragmented it? Like we have removed the ethene group, and after removing of the ethene, phenol is formed that has a mass of 94. Similarly for diethylamine, if you will just remove the methyl radical, then you will found a mass of 58. But then after further rearranging it by removing of the ethene moiety, you will get this form that has a mass of 30. Is it clear?
Yes, ma'am.
Actually, this much question I don't think it will be asked in exams. But how fragmentation occur, you should know that. Like little bit like simple questions can be asked, but they will not ask specifically by the names. Maybe structure will be given or simple molecular structures with simple names like phenol, anisols, that are common names will be given. But like phenitol, etc., will not be given. Like pantanoic acid is can be given, diethylamine can be given, but phenitol, like this much, or if there be phenitol, then there will be structure will also be given. Now in the next question, an organic compound with a molecular mass gave the following spectral data. For the UV, there is no absorption band above 200. For IR, there is a significant absorption band at 2940, 2270, 1460. And for proton NMR, septate doublet is formed. So you have to find out the structure. So from UV, what do we know? Like there is no absorption band above 200. That means there is no conjugation.
No conjugation.
Yes, and IR, like in IR, if the peak is at 2940, what does it mean? Which group indicates? Which functional groups comes at 2940?
Methyl.
2940, it's CN, Sino 1.
Yes, 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 I know.
2940 is Sino, C triple bond N. 2270 corresponds to CH stretching, and
See, yeah,
1460
that
corresponds to CC stretching.
CC.
Now just tell me the structure. If it is septate and a doublet. See, when it will be septate means the structure will be in this form. And you have a Sino group. Now just see. For this one, 3 plus 3, 6, 6 plus 1, 7. They will be septate. And for these methyl protons, there will be one hydrogen. So 1 plus 1, that is doublet.
Doublet.
So structure will be this. Is it fine?
Yes, ma'am.
Now next question. How will you distinguish between isomeric alcohols with a molecular formula C4H10O? C4H10O means you are having 4 carbons. Alcohols, it is OH. Isomeric alcohols means it can be primary alcohol, it can be secondary, it can be tertiary. So now if you will look at primary alcohol. So this is the formula, molecular formula CH3, CH2, CH2, CH2OH. For secondary alcohol, it can be CH3, CH2, CH, OH, CH3. For tertiary alcohol, it can be CH3, C, CH3, CH3, OH. Is it fine?
Yes, ma'am.
So now how you will distinguish these three structures by mass? By fragmentation, because M by Z value will be
Fragmentation.
different. Yes.
Yes,
So
yes. First
if you
for primary and secondary industrial.
so if you'll fragment the first one, how you will fragment this? Simply you can remove the water molecule here. Like if your structure is this, so this water molecule can be removed. So the corresponding M by Z fragment will be of mass number 56. Now from here, the secondary alcohol. So from secondary alcohol, what can you remove? You can simply remove the ethyl radical, or you can remove the methyl radical. Correct? In tertiary alcohol, you can simply remove methyl radical, this one or this one or this one. So in all case, the fragments will be of different mass. Suppose in secondary alcohol, you are removing the ethyl radical. Then the mass, then the fragment will having 65 mass. Sorry, 55 mass. Similarly, in tertiary alcohol, if you will remove one methyl, so there can be C methyl, C methyl, this methyl you are removing, then OH. So what will the M by Z value? It will be 59. Is it clear?
Yes, ma'am.
So in this manner, you can distinguish using mass. So fragmentation can be any, but you have to see in question what is the M by Z value provided. Corresponding to that, you have to fragment it. So, so that's all for today. Is there any doubts regarding mass?
Ma'am, I have posted two questions in the chat box. I am not getting formula for that question. Can you please take the question?
Actually, I don't know. My screen is not working. I can't like open the chat box. Can you just tell me?
Actually, ma'am, the questions are from week two. Problem solving session week two. You have conducted these two questions. You have solved, but I'm not able to understand because the whole session you are conducting, na, your screen is only one slide is going on during that whole session. Hence, you are solving, although you are solving on your screen, but on the video it is not getting.
Okay.
Hence,
So what
all
was the
these things
question?
not. Question is 1 minute. Question is that determine the energy that must be given to hydrogen atom so that it can emit second line of Balmer series.
Second line of Balmer series means Balmer series is what? The transition is from the second orbit.
And you start second, yes, yes, n is equal to 2. But I'm not getting formula for the energy. That is, you have calculated the energy in electron
Energy, like
volt
see
as
now,
well as in.
firstly we know the formula of wavelength in terms of Rydberg's constant, na? Like we know that Rydberg
Yes,
constant
yes,
formula.
yes, yes,
So
yes.
from that you will calculate the wavelength, and when you will get the wavelength, then you will apply the energy formula. That energy equals to h mu, that is h by lambda. H and c are the constant, and wavelength you will calculate from that formula. So therefore you will
Yes,
calculate the energy.
firstly we have to use which formula, ma'am?
That Rydberg's formula one.
Rydberg formula. Okay, ma'am. From Rydberg's formula, we will get the wavelength, right?
Hmm. We have solved the same
And
question like multiple times, like the same question, na?
sorry.
Like the same questions we have discussed multiple times.
Yes, I
Like
two
Rydberg
to three times
constant
I read it.
multiply by 1 by n word square by 1 by n2 square, that one.
Yes. Yes, actually, I was not getting which sequence that formula. Hence, I am asking you. First will be reverse constant. We have to calculate reverse formula we have to use, and from that we will get the wavelength.
Read were
And
constant like
by using
109677.
uh,
Yeah.
yes, from that we will get the wavelength, and from the wavelength we have to calculate the
Energy.
energy. That is why the formula E is equal
Hmm.
to Sc by lambda. Right?
Correct.
From that we will get in joule, and we have to convert it in electron volt by dividing 1.6 into 10 raised to power minus 19.
Correct.
Yes, yes. Actually, I know the formula is equal to Sc by lambda. I'm not able
It's
to
fine.
recall Rydberg's constant is there. Hence, I asked you that.
Because whenever we are talking about the Balmer series, Lyman series, now we were using that formula only, na, like n1 square minus 1 upon n2 square, that one. We
Yes,
have
yes,
to
yes.
focus on
Since
each
the ma'am,
time.
since the ma'am screen is only
No, it's
when
fine.
once you have
It's fine.
started that, yes, yes. Once you have started the sessions, only first slide is
Actually, there is
visible
some
from first
problem
to
in that
last.
recording one, yes.
Yes, yes, yes.
Hmm.
If possible, in the next session, please try to get some this question, one or two question,
Okay,
if
like
possible,
we
so,
will have some
so that it
extra
will
class
be.
on Saturday, this Saturday.
Yes, ma'am. That will be last class, ma'am.
That will be the last class, and that will be only for 1 hour.
Okay, okay. It means you will cover all from
Yes,
most as much as possible of 12 weeks important question like that
yes, that will be an
or
extra
important
session.
topics.
That will be an extra session.
Yes, 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 yes.
And what is the
Yes.
second question?
Second question is just after that question you have discussed the what is calculate the wavelength of electromagnetic radiation emitted by hydrogen atom which undergoes transition between energy level of minus 13 points 1 point minus 1.36 into 10 raised to power minus 19 joule and minus 5.45 into 10 raised to power minus 19 joule.
This you can also calculate from the same.
Yes, Rydberg's. I think that can be calculated using Rydberg's formula,
Correct.
Rydberg's constant formula,
Hmm,
right?
correct.
Yes, yes, yes.
Now energy is given, na? Both energies will be given. Then correspondingly you will calculate.
Although other yes, yes. Although others question I have solved successfully.
Okay.
Only these two questions are remaining.
So
Hence, I
today's
asked.
session was clear. Like everyone was facing some doubts, na? Like about bromine, chlorine. Like now it is clear now. How do we solve it?
Yes, ma'am. Yes.
Okay. Thank you. That's all for today.